Hello friends, today I'm planning for modeling and shaped analysis of a spherical vessel used in cryogenics. We are planning to conduct this modeling and analysis in two separate videos. First part will be modeling using SolidWorks and second part also will be shaped analysis using SolidWorks software. In this special type of spherical vessel, we will force helium at a high pressure and low temperature, and outside temperature will be 28 degrees centigrade. So heat transfer will be occurring between the different walls and inside the container. So here in this case, we will see that phase change of this helium will take place. It will be converted from liquid to gaseous stage, and so it will be evaporated from this small opening, right? So without wasting time, let us start modeling of this one. Starting from part. And we start modeling from front plane, normal to, starting with central line. Now we can start this arc. Let us draw semicircle. And another semicircle is equal. Let us provide smart dimension to this one. Before that, we can join the two close edges, and that will be revolved later on to get the spherical part. Now we can provide smart dimension to this one, as inside radius is 475 millimeter. And outside one is 500 millimeter. So exit from the sketch and features evolved pose base with respect to the central line. We got the internal part of this spherical container. Now we have to provide some leads, right? And not only leads, we have to provide some input and output locations. And for that, let us take this front plane and we can draw it again with central lines. Let us draw two center lines with a specific angle. Let us take a smart dimension to this angle in between these lines, and we are providing the angle in between them is 45 degree. And let us take the distances of the height of these things as 700 millimeter. And both of them we want to have 700 millimeter height. Done. Exit from the sketch. Now what we want to do at this location, we want to provide input, and that one will be output end, right? This one will be from this location. We will be forcing helium at a high pressure and low temperature. As inside this container, this helium will be undergoing phase changes from liquid to vapor, so it will be evaporated from this small opening, right? So we have to get these openings right now. Select that point, and we want to provide one specific plane on this one, and we have to create those openings, right? So features, then geometry, plane. One plane is made that is parallel to this line. We have to make it perpendicular to this line. So now it's perpendicular to this line. Green check. Now on plane 1 we have to provide that opening. So normal to that plane we can draw some profile, some circular profile we can draw here in this at this location. Smart dimension, this one let it be 100 millimeter. So exit the sketch, select the sketch again, and features, extrude cut. Want to cut up to next. Done. You can check by viewing from specific plane that is cut already, right? Fine. Now again on that specific plane we have to draw another circle, another concentric circle. Plane normal to sketch, concentric circle we are making. Let us provide smart dimension to these two circles as 100 mm and 200 mm. Now exit from the sketch and that to be extruded. Select the sketch, features, extrude boss base up to the surface. We select up to the surface. Let us select the surface up to this one. Grid check. It's done. You can see a similar operation we have to do on this point also. Now let us hide this plane. Select that point, reference geometry plane. Now this plane you have made, which is parallel to this line, you have to make it normal to this line. So click the line again. Now that plane is perpendicular to this line. Accept that plane, and on that specific plane you want to draw similar type of circular profile. Plane normal to sketch circle. Here at this location you have to provide a circle of diameter 25 mm and that to be cut through 25 mm. Exit from the sketch, select the sketch again and that to be extrude cut, features, extrude cut up to next. You can reverse the direction. It is cut, again check, accept it. So you can see it is cut through. Okay. Now on the same plane we have to provide two concentric circles again, like previous cases. Select the plane normal to, plane normal to again. Now we have to draw two concentric circles at this location, right? So sketch circle, two circles we are drawing. Let us provide smart dimension to these things as 25 and 50 mm. This one is 50 mm. The small one is already 25 mm. Done. Exit from the sketch. Select the sketch again and features that to be extruded. Features, extrude boss base up to the surface. at the top of this spherical container. Grain check, done. Right, you can see this is actually the inner part, right? So let us hide this plane. We can consider the complete model, right? We can put some specific color to this one. Let us provide color of glass. So we have provided glass to this material and save this part as inner part. File save as inner part spherical shell. Inner part shell. Now we can close this box and we can start the outer part. Let us start from new part again. Part. Okay. Like the previous case, we have to draw from the front plane. Normal to sketch. Central line. Now what to draw? Two semicircles. One semicircle done. Another to be drawn, and that to be drawn in anti-clockwise direction. Now we can make this drawing closed with some straight lines. Now let us provide smart dimension to this one, as inner one will be 550 mm. And the external radius will be 600 mm. Exit from the sketch. Select the sketch again and features, evolve pose base. We got the external part. Grain check. Now we have to provide that openings. So we can select the front plane again, normal to. Start with the sketch again. Central line. We can draw two center lines with a specific angle of 45 degree in between them. So smart angles. In between them we are providing an angle of 45 degree. Exit from the sketch. Let us select any point. Features, reference geometry. We are going to provide a plane on that one which is perpendicular to this line. Now at this location it is parallel to this plane, parallel to this line, so we have to make it perpendicular. So click that line again. Now it is perpendicular. Accept this one, and on that plane we have to provide that opening. So sketch, circle, and this one will be smart dimension as 200 mm. Select the sketch again and features extrude cut. It will be up to next. Grain check. Accepted. It is a cut, right? Now the same thing to be done on this point also. Reference geometry plane. Now select that line again. Now it is perpendicular to this line. Accepted. On that plane we want to make this one perpendicular to this point. normal 2 again, sketch, circle, smart dimension to this one, it will be 50 millimeter. Can check, exit from the sketch, and we have to provide an extrude cut to that one. Extrude cut, we have to select that sketch, and we have to see it will be in the opposite direction, so we can reverse the direction, and we want up to next. Green check, accepted. So we got the cut. Now we can hide these planes, and with the cross-sectional view of this one, you can see whether the cut is okay or not. Okay, fine. This cuts are okay, so accepted. You can provide color to this one as clear glass. Just see the complete view of this model and provide color to this one as clear glass. Done. Save this body as outer shell. Save. Next one, we have to assemble these two things, right? Go for assembly, part, assembly. Okay. Now we have to bring those parts, inner part and outer shell. Okay, by browsing, you can select those parts. It will be inner part shell and outer shell. Let us open these things. This is the inner one, and this is the outer one. The first one is fixed, the second one is floating. Now what to assemble these two different parts together. For assembly, we'll combine all these planes together. So starting from assembly, met, want to make the front plane of the inner part with the front plane of the outer part. Green check. Two planes are parallel right now. Next one, the right plane of the external one should be meeting with right plane of the inner one. Green check. Accepted. Now the last one, that means top plane of the inner part should be meeting with the top plane of the outer part. Green check. Accepted. Done. We can see the model with a sectional view. You can cut it along specific planes. Suppose we are cutting along the front plane, we can see. Green check. You can see here. So it is perfectly done, right? So from this opening, we will force helium inside this container or a spherical container, a spherical vessel. Phase change of helium will be occurring. From liquid, it will be converted to gaseous stage, and finally it will be evaporated from this very small opening. Outside temperature of this container is 20 degrees centigrade. Okay. Now this is the model. We can hide these central lines. This one also we can hide it. Now you can see the complete view of this model. Our model is ready for our simulation or analysis. Okay, done.